In this unit, we're going to concentrate on the cloud platform and cloud infrastructure and some of the security concerns with cloud infrastructure. So we'll talk about the physical aspects of the cloud environment so we understand the physicality of where things are located in the cloud and how and what we have to worry about as far as our data that's in the cloud and our usage of the cloud. We're also going to talk about some of the components that make up a cloud environment. We're going to go through some of the risks associated with the physical cloud components and how we can mitigate some of those risks and how we use the cloud to mitigate our own risks. So we'll talk about it in both senses. Designing and planning for cloud-based security controls, auditing a cloud environment, and disaster recovery and business continuity in a cloud environment. So we'll cover that last. So let's start with the components. So for cloud components, you have, and we'll talk about these components in the following slides, but basically we break it into these two sort of overarching components, which are the physical hardware and environment, and then the management plane, which we use to manage all of our virtualization, which is on the inside of this diagram. So you have your hypervisor, which we've talked about what our hypervisors are. You've got some kind of storage platform. You have some kind of computing platform, which is typically used by the hypervisor, and a networking platform, so some kind of networking infrastructure. And that's virtualized as well. We'll talk about some of those aspects of virtualized networking as well in this unit. And all of that runs in a physical environment that we have to be aware of, or at least be aware that it exists if we're using the cloud, but also how we can use the cloud to mitigate some of the problems with physical hardware and our physical environments. And the management plane is how we access all that stuff. So, so let's talk about, so in the cloud, in cloud infrastructure, it's a little different than typical IT infrastructure. A cloud service provider has to worry about most of these things. And I think most people that are probably taking this class, most of you are not going to be a cloud service provider or work for one, but I mean, some of you may. But why do we care about what about the cloud service provider and what they do? Because it's important to understand what the risks are associated with the cloud and the physical environment, and understand why they need to take some of the measures they do, some of the things that we need to look for in SLAs and things like that, understanding the realities of their business. So the first thing is there are hundreds of thousands of servers in a cloud service provider's infrastructure. Looking at companies like Microsoft, which has the Azure cloud environment, Amazon, which has their cloud environment, and of course Google, and even some of the smaller ones like Rackspace, they have tremendously huge infrastructures with hundreds upon thousands of servers. And not necessarily hundreds or thousands, but hundreds of thousands, so 100,000 some odd servers and so forth. So it's a pretty huge scale. So per square meter, the power density is as high as 10 kilowatts. That's a lot of power. All these servers crammed into such a small area. And when you look at some of the cloud service providers, I would encourage you to take a look at Google has a lot of videos where they show you a little bit about how their data centers work and how their cloud infrastructure works, and a large part of that is looking at how they deliver power to these huge data centers and some of the methods they use to generate that power and to mitigate the risk of power failure. Sometimes they locate their data centers where they can generate their own power from hydroelectric plants and things like that. So they take some pretty big investments to do some of those things. Enormous and immediate impact of downtime. So if you think about any of these cloud service providers, any one of their data centers could be servicing thousands upon thousands of customers, maybe even tens of thousands of customers, or even hundreds of thousands of customers. So a downtime in one of those data centers could have a tremendous impact on not just their business, but everyone's business. Basic services that are provided by the cloud service provider are power, pipe, and ping. So power, so the basic service of any data center is providing power to power all the servers, the pipe, which is the network, and ping, the ability to connect. So that's where they come up with the term power, pipe, and ping. You might hear that in the industry. And advanced cooling and power requirements. You can't have a data center without cooling, and you can't have a data center without a lot of power. A single rack of servers. I'm sure all of you have seen server racks, but just a single rack could require a 100 amp circuit, and then and if you take a row of 100 racks, that's a lot of power, right? So power is certainly a major concern, and how to deliver all that power safely, efficiently, and of course redundantly. And of course, cooling is also a huge concern when you have this this high density of servers running in a data center. there's going to be a tremendous amount of heat that's generated, and that heat has to be displaced, and you have to use cooling equipment. And I would say that for many data centers, the cooling costs probably rival those of their power costs. Cooling is, as most of you probably know, cooling is expensive. You know, running your air conditioner in the summer is expensive, and our homes don't have rows and rows and rows of servers kicking out a ton of heat. So it is important to make sure you have adequate cooling. And I've worked with just recently a data center that I was using had a cooling failure. Actually the service provider that was running a co-location decided to turn off their air conditioners because I guess they couldn't afford it. I'm not sure exactly what the deal was, but one of the data centers that we use, we found out that we started getting alerts that some of our servers were overheating, and I drove down to the data center to find that the temperatures inside the building were upwards of 120 degrees inside, and inside the actual racks were over 180 degrees, which servers don't last very long when they run in those types of temperatures. So the data center was basically useless to us. I had to shut everything down and transport the equipment to a different data center. And that was a company called Net Carrier that's in the Philadelphia area, and I believe they never actually turned the cooling back on in that data center. So you have to watch out for those little providers like that certainly don't have the ability to provide the services that we need for high availability and so forth. So we have physical redundancy. I think we've talked about physical redundancy before. So you'll have backup power, you'll have multiple cooling units. So instead of just one air conditioner, you would have many, many air conditioners. And generally, like anything else, you calculate the cooling load of the data center, and you make sure you've got enough cooling so that if you lose any of the cooling equipment, you can still cool the space. Multiple power lines. So again, you calculate the power utilization, and you make sure you've got enough power coming into the data center. Now, the problem with power, it's easy to make everything redundant, but think about your home. If you wanted to have redundant power coming into your home, now we have some options with things like solar and so forth, but in the old days, multiple power sources, you would have to have something like a gas powered generator to be your backup source. So there are ways to get backup power, but typically you're not going to have multiple utilities servicing a data center unless you're in a unique area. That's not very typical. So you might have to make your own electricity or have your sort of a backup plan to provide some electricity. Multiple building entrances, multiple PDUs, multiple points of service for power and network, and so forth. So it's all about redundancy. So we want to make sure we have redundancy in our physical plant and our physical data centers. And that's, that goes in any area of IT, but especially so for cloud, because as we talked about, the impacts of downtime are so much more acute with cloud service providers. So as far as networking and communication, so cloud computing first level terms with network and communication, you have the cloud consumer, which is the person or organization that maintains a business relationship with the cloud service provider. Then your cloud service provider is the provider that's making cloud services available to us. So that would be somebody like Amazon, Google, or Azure, and so forth. And then you have a cloud carrier, which is an intermediary that's providing some network connectivity. So some of the network functionality that you would expect from a cloud service provider is address allocation, providing IP addresses to cloud resources. In other words, when you went into Azure and created your Azure virtual machine, it got an IP address, so they allocated that IP address to you. You didn't have to go out to IANA and request an IP address and all that sort of thing. They sort of take care of all that on your behalf. They provide access control, so mechanisms for granting and denying access to resources. Again, you should have seen that with the Azure Labs when you created your Azure environment. Bandwidth allocation, so resource bandwidth shaping. For those of you not familiar with bandwidth shaping from your network classes, that's where different types of traffic can get different priorities on your network. So real-time communications like voice and video and so forth, you might have a higher precedence than, say, just web browsing or something like that, where latency might not be as noticeable. And to that end, there's also rate limiting, which is how we can control the rate of traffic to resources. And that's important in the cloud because one of the things that we're being metered on in the cloud is our utilization of resources like the network. So in many cases, we need tools to make sure that we can cap our utilization. gosh, it would sure be nice if our power company would do that, right? If they would give us a way to cap our power usage if we wanted to, so that we don't get a huge bill at the end of the month if there's something wrong, right? Or your water bill. I don't know if any of you have experienced that where all of a sudden you get a water bill that's $1,000 because maybe you had a sprinkler that got punctured underground, or a running toilet. Just a simple running toilet sometimes will drive up your water bill. But it'd be nice if you had some kind of an alert that tells you that that's going to happen. So cloud service providers can do that for us, and they can allow us to do rate limiting, and they can rate limit even clients that are paying for bandwidth. And then filtering, selectively denying or allowing content to access resources based on rules and so forth, and routing, which is how we direct the flow of traffic within the cloud infrastructure. So these are some of the network and communication services that we expect to see from a cloud service provider. One of the things that the cloud service provider does that's a little different than in our own data centers is software-defined networking. And so software-defined networking is basically when we decouple networking from specific hardware. I think most of us are familiar with networking. We ask somebody, hey, what kind of firewall are you running? And they might say Barracuda or Cisco or whatever, or SonicWall, whatever type of firewall, or NetScreen. But what you're really describing when you say that is the hardware. The hardware for that device. But in this new sort of cloud world, a lot of these things are software defined. In other words, rather than being a physical device, I mean, there are physical devices that underlie all this, but instead of being a physical device, it's all software driven. So it's software that's controlling the network and access to networks and so forth. So it's application programmable networking. So instead of having switches and routers and firewalls and proxy servers that are physical devices, these are all software that you're accessing in the cloud that you're using for your cloud environment. If you think about it, it'd be very difficult to have a cloud service provider offering firewall services through physical devices like you and I might be used to in a data center or a home office, or something of that nature, because every single customer would have to have some physical hardware racked up somewhere, and that's not scalable. So they found a way to do this with software. Most of us don't use software-defined networking in our own data centers because for most moderate to small-sized data centers, it's not needed, which is the vast majority of organization-owned data centers for most corporations and organizations in this area. But if you're a cloud service provider, or if you're using the cloud, you want to make sure you understand the software-defined networking components and how that works. Then you have some computational power that has to be available. So some of the parameters that we talk about are number of CPUs and the amount of memory. We've talked about that before, and how that's scalable and how that's flexible, and and all those other things that we talked about with the cloud that makes the cloud a good platform for for computing that's metered, as we keep talking about. So virtualization allows us to share resources, which gives us efficient, agile use of resources, which is great. Ease of management, because we can log into these portals to do whatever that we need to do. But we'll talk about some of those risks here in a few minutes that are associated with that. And of course, scalability, and as we talked about before, we can scale it up very quickly. And then, so storage. So as far as storage goes, I've talked about different types of storage that we can do in the cloud. Most of the, so the storage that I talked about as far as hierarchical storage, the traditional sort of mounted drive storage, the security concerns with that are very similar to what we would have in our own data centers. Object storage, which is unique to the cloud for the most part, although I don't know, sometime in the near future we might see object style storage available to us within our own data centers, software that enables that to happen, so we don't have to have a model where we're using SANs or something like that. But object storage, it can be fragmented and duplicated much differently than hierarchical storage, and it's exposed through APIs. The reason we use APIs, or what makes APIs great for object storage, is it gives you a layer of abstraction between the hardware and the storage platform. So in the software rather. So I can store, if I have software that can use object storage, it doesn't matter what type of hardware it is. It doesn't matter where it's installed. I can just call that API to do the storage, whether it's in Azure or Google or Amazon or whatever. It doesn't matter. But the fact that I'm accessing that storage through an API can also be a security concern because APIs have risks. They're application level. There are lots of known vulnerabilities, and APIs are very well understood by attackers and how to take advantage of those. And I'll talk a little bit more about that in our discussion on risks in this unit as well. And changes can take a long time with object storage. I recently started migrating a large data store. I mean, it was only 60 terabytes, but migrating 60 terabytes to object storage from a standard SAN to some object storage platform is incredibly time consuming because you have to, for each file, you have to generate some kind of an index in some metadata, and that might be in the cloud through some kind of cloud-based database engine like Azure SQL or MySQL hosted through Google or through Amazon. And then after you do that, then you have to call an API to bundle up that data into some kind of packet, some kind of package that you can use with an API or envelope that you can use with an API, and then you have to post that data to the API, which can take some time. There's a lot of chatter back and forth. Then you move on to the next file. So it's not as simple as just copying files. So replication from a traditional storage environment to object storage, and also to replicate it within object storage. So if I have all my objects stored in one cloud provider and I want to move it to a different cloud provider, that may take some time to do that. And we'll talk about some ways to mitigate that here in a few minutes. The management plane is also has some security risk. But what do we use the management plane for? The obvious thing is for creating, starting, stopping instances. So when you set up your Azure environment in the lab, you probably started and stopped you probably created, started, and stopped your instances of your virtual machines. There are lots of other things you could do in the management plane. So when you signed into Azure and you saw all the different things you could do, you could set up your databases, you could set up your networking, you could sign IP addresses, you could do your firewall, all those other things that we looked at in Azure all reside within that management plane. The thing about that management plane is that it allowed you to do pretty much anything, right? So the management plane is sort of like having the keys to the data center. It's like being able to walk into the data center and walk down rows of servers and do whatever you want with those servers because you have physical access to those machines. So that's certainly one thing that we have to be aware of. The other thing is these management planes typically have APIs. So either they're exposing functionality through APIs, or we're using a web browser to access all this functionality through a web browser. Anything that's in a web browser, anything at that application layer that's available on the wider internet, it certainly can have some exposure as far as our security concerns go. So it's something to be aware of, and certainly something we need to understand. We also want to make sure that we're very careful about who has access to the management plane in the cloud provider. It's one thing to give access to the application level resources that are in the cloud, for our users, but to give access to this management plane is sort of the next level up. You wouldn't give access to the management plane to anyone whom you wouldn't give access to the physical data center. To somebody who's got the keys to the data center or who has administrative logons to computers. Those are the types of people that would have access to that management plane.